Manager, good evening.
Good evening, sir.
We'll wait for another 4 minutes, 3 minutes.
Yes, sir.
The student join, then we'll start. It's at a 7:05 we'll start.
Yes, sir. Yes. Is my screen visible?
Yes, yes.
Okay. So, good evening, everybody. Today, we'll start the ML pipeline from where we have left in the last class. So, let's discuss that one. So, in the last class, we have discussed um, why we or what is ML and types of ML. Today, we'll start that to solve a particular problem, how we can use ML and what is the step-by-step process. And we call it as ML pipeline. Now you see, for any machine learning problem to be solved, we need data. The data is very important because already we have seen that if you got a problem and that problem cannot be solved by the traditional programming approach because we do not know how to solve that problem or what is the formula to solve it or what is the procedure to solve it. So for that we use machine learning approach. So in machine learning approach, we need data, and particularly for supervised machine learning approach, we need data which is level, which has labels. So the data is a first step. You acquire the data, and how you will acquire the data, that we'll see. You acquire the data. Once you have the data, then second step in the ML pipeline is pre-processing the data, because the data whatever you collected or whatever you have got, that may not be in a proper format, or that may not be in a cleaned way which the ML is going to be taking to use it. So for that we need some kind of pre-processing activity, and mostly this pre-processing activity is very important. And not only in ML, when we'll deal with NLP, also their pre-processing is very important. So the pre-processing part, if you do it clearly or quite means in a well-defined manner, then whatever data comes out is the cleaned data, and that will be used by any model to give you better prediction. Okay. Third step is feature engineering. So the feature engineering is sometimes the data set may not have the feature what we need to solve the problem. So from the existing feature, how you can create new features which will be good predictor for the prediction task. Or in NLP case, we do not have any tabular format because it is unstructured data. In that case, what kind of feature engineering we can do so that the data set what will come out from the original data set, that will be better to be used by any model to solve a particular problem. Once we do the feature engineering, fourth step is modeling. So in modeling, we use any ML or deep learning models. Whatever algorithms available, these algorithms can be used to learn a pattern from the data set. The data is clean data. We have the, if it is a supervised case, we have the data and its label. So the modeling is basically taking some algorithm based on the problem, because there are many algorithms available or there are many modeling techniques available which will be used, that you decide depending on the task and the data set, and then apply that algorithm to find out a model or to train a model. So this is the modeling. Once a model is trained, now whether that model is good or bad, we need to evaluate it. So there are some evaluation criteria, performance metrics are there. Using that performance metrics and evaluation metrics, we will have to test whether my model, whatever I have created out of the data set, is good or bad. Once you satisfy that my model is a good model, evaluation says that yes, the model what you have created is a very good model, then that trained model can be deployed in real world, so that whenever the same problem arises and you got the new data, the model can predict the answer. So this is the step. So today we'll discuss this first three part. Tomorrow we'll discuss the last three part. So first, see what is data. So for data, we need some data acquisition methods. Means from where we'll get data. So we call it as data acquisition. That means acquiring the data. So data acquisition, basically it is nothing but the process of collecting, importing and measuring data from different sources of analysis, for analysis, processing and machine learning applications. That means if you do not have anything, you just got a problem, and the problem cannot be solved by the traditional programming approach, then you move towards the machine learning approach. For that, you need to collect data. For solving that problem, you go and see that for this problem, what was the historical data and what was their result. You collect these as many data as possible. That is called data acquisition. So it is very important part of any ML, for any ML technique to be applied on a particular problem. Why it is very important? Because we know that if we want to use ML, it must need data, because without data it is difficult for the ML model to operate. So ML models learn from data. That's why data acquisition is very important. And not only you collect whatever data you got, but the data must be in a better quality. Poor quality data is lead to poor prediction. The data must be cleaned. So that's why we need some pre-processing step. So in this data acquisition step, you just keep in mind that for my problem, what was the good data and what is their corresponding result. You just collect that. And because we know that if you have better data, then it improves the model accuracy. So, but generally, when we apply any machine learning model for our training purpose or for learning purpose, you got many data sets. Already the data sets has been curated by somebody. Somebody has collected the data and filter it, clean it, and they put in a data set format. Basically, we are using that. Otherwise, if you got a new problem and there is no such data set available, then you can create your own data set. For example, let's say you want to solve a sentiment analysis task in NLP, and you are trying to use your ODI language. Means you go and see there are many YouTube videos are there. People are discussing many things on YouTube videos, and you got many comments on that YouTube video. So let's say you collect those comments, and those comments are basically ODI comments, means written in ODI language or in any regional languages. So basically, it is difficult to find a data set on these languages. There are data sets available, but if you want to create, you can create. You collect all this data and label it and create a data set. Now you got the data set, then you can apply the ML pipeline to solve a particular problem. So this is one. But if the data set is available, so we can use that. So that means, what is a data set? So data set is nothing but it is an organized collection of data used for training and testing machine learning models. So sometimes people already let's say this is a very famous problem and people want to solve that problem. Many researchers have created the data set. They have collected, they have curated the data set, organized and placed in any website so that any researcher or any individual can access the data set and try to solve similar kind of problem. Okay, and this format, and the data set already we know. For ML model, the data set is a structured data set which has features, we call them as X, or input variables. Let's say like age, salary, date of birth, etc. Maybe the feature, and output is Y, we call it as a label. Let's say whether the person is going to purchase something or not based on these features or based on these independent variables. So this is data. So from question is from where you will get the data set. So there are many ways to get the data set. And before that, let's see what are the types of data set available. Basically, there are three types of data set. One is structured data set. That means they are organized in a tabular format like CSV files, Excel sheets, etc. And they are easy to use by the ML model. So ML model can easily use this structured tabular format data. So even if you do not have that kind of data, what you can do, you can convert a unstructured data to a structured data or tabular format data. Then only you can apply the ML model. Another is unstructured data. There is no fixed format like text, images, documents, audios, videos. They do not have any fixed format. So if you want to analyze this kind of data, then one way is that you can convert them into a tabular format. Means find out important features from these data and label of this data. Or you can use improved instead of using ML technique, you can use deep learning technique where you do not have to do these manual feature selection or feature creation. Directly the unstructured data can be given to different DL models. That also we'll see, because basically we'll deal with text. So text is an unstructured data. So how this unstructured data will be used, that we'll discuss when we'll discuss the deep learning model, and also in simple NLP task. In that also we'll discuss. Third one is the semi-structured data. Semi-structured data means they are partially organized, partially unorganized, like JSON files, like XML files or XML data, like HTML files. So if you use these, there are certain kind of structure, but some inside the structure, whatever data is there, they are unstructured. Like in a HTML file, between two tags, some sentence has been written. So that is unstructured, but the format, the template is structured. So that's why we call them semi-structured data. And for our case currently, we will discuss basically we will discuss on structured data set, how the structured data set will be used for ML applications. And when we'll move to the NLP, we'll discuss this unstructured data set, how we'll deal with the unstructured data set. Okay, this is the first. And question is from where we will get the data set. So there are many public data set platforms available. Most famous is Kaggle. From Kaggle, you can get different kinds of data set. Another one is UCI machine learning repository, which is a very old data set repository of University of California. There is, if you want to search a data set, you can use Google data set search. Like you are searching, you just type data set search. You will go to that page, and whatever you want to search, you put the data set, and it will show you different data sets from different places. Okay. Another data set is Hugging Face data set. Now it is means very popular in NLP world or in any deep learning world, that most of the data set are now shifting to Hugging Face. Another thing, another source I have not mentioned here is the your GitHub. In GitHub repository, people are also putting some data sets. So that from that also you can get. So what are the characteristics of good data set? So good data set must have sufficient data size, means good number of examples or rows must be there. The labels must be accurate, and the classes, if it is a classification data set, it should be balanced classes. Balanced class means, let's say you want to do a classification task and the output is whether you are accepting or rejecting. Let's say some application is there, you are accepting or rejecting. This is the class, and you got let's say 50,000 data, 50,000 rows. And for 50,000 rows, if you want to say whether that data set is balanced or not, that means The number of, it is a binary classification problem, accept or reject. So the number of data points for accept and reject is must be nearly equal to same. May not be exactly same, but nearly equal to same. But if a data set has imbalanced nature, means let's say the yes or the accept is 90% of the data is accept as a level as accept, and 10% is let's say reject, then this is an imbalanced data set. And even if you train a model, it is not generally do well. So for that, generally we do balancing before doing any ML algorithm to be applied. And missing value should be minimum, and the features whatever is there must be relevant to the target, because the features will be used to find out the target or map the to the target. If your features are not relevant to the target, then even if the data set you collect, that data set is not going to solve your problem. Okay, so this is the first part. Once you have the data set, then you have to see that whether the data set has missing values, whether the data set has duplicate records, means same record multiple times, or is there any noise or inconsistencies, or the data set is imbalanced, or is there any privacy issue, because sometimes you without the knowledge of the source, or without the knowledge of the provider, original owner of the data, you have collected and published the data set in public, so there is a privacy issue. So or let's say you want to create a data set of medical records for some individual, so these are the private documents, so without their consent you cannot create a data set and make it public. And these are the challenges of the data set. So what we need high quality data set that are the foundation for successful machine learning systems. So if you want to solve a particular problem using ML, the most important is your data set. High quality data set is required, but the data set may, even if you collect in perfect way, these kind of challenges may be there in the data set. That's why we need second step, we call it as data pre-processing. So we need pre-processing activity, because even if you take so much care to create a data set, still there may be some problem or noise may be there in the data set. So how to tackle? Because if your data contains noise, whatever model you learn out of these data is not going to give you good result. So for that we need pre-processing. So why we need it? Because generally the data is often noisy, and the problems with the raw data is there may be missing values, there may be duplicate records, incorrect formats, outliers may be there, and the consistency is not maintained throughout the data set. So we need pre-processing activity, because the idea is ML model cannot learn effectively from noisy data. If data contains noise, then it is not going to give you any good result. So we need pre-processing. But before pre-processing, one step we have to do, or the pre-processing involves basically two sub-steps. One we call it as exploratory data analysis. So when I say that the data contains problem, means missing values, noise, outliers, so how will know that? Where is the missing value? Where are the outliers or any problem? First you have to identify. So to identify the problems in a data set, before doing pre-processing, we have to do exploratory data analysis, that is called EDA. What is EDA? It is the process of analyzing and understanding a data set before applying machine learning. We just analyze the data, find out where is the inconsistencies and problems, and once you got these places or inconsistencies, you identify that, then you do the pre-processing. And once you do the pre-processing, the data will be curated, will be cleaned, then you can apply the machine learning models. Okay, so what it helps? It helps to discover patterns, detect problems, make better decisions about pre-processing, because you cannot directly apply pre-processing. For pre-processing, let's say I say there are missing values. So where is the missing value? Whether the missing value is kind of missing values are there. So that you need to identify whether the outliers are there, whether they are important or not important. So that you need to do. So for exploratory data analysis, these are the steps. First, you load the data. Then you inspect, basic inspection. What is the data contents? Just customize yourself about the data present in a data set. Then do the cleaning. And if it require to visualize what type of data to get more insights about the data, you can do the visualization. Once you have this, then you go for pre-processing, because by these four steps, what you will do, you will identify the inconsistency in the data set, and you will have a better decision power that what kind of pre-processing we should apply on these inconsistencies which is identified during the EDA. Is it okay? Next, what are the goal of EDA? So the goal is, first you understand the data, because the data is very important. You, whenever you are a machine learning practitioner or you want to solve a problem using ML, you need to customize or acquaintize yourself about the data. What is the data? So that is called understand the data. That means identify what type of data it is, what is the type of variable types like numeric, categorical, date or time, etc. Then you determine the shape of the data set, means how many rows are there, how many columns are there, and recognize the relationship between different variables, between independent variable and dependent variable, means which features are actually going to help in producing the output variable. So that you just try to figure out by showing, by doing this kind of analysis. Once you do that, once you know that these are the basic things in the data set, then next step is to find out the missing values. Wherever you got a data set, the data set may contain missing values, so you have to identify that. That means identify the places of missing values. Missing value means the value may be absent, or during data collection you forget, or the collector do not forget to collect that data and has not put in that field, so it is not recorded. So that can be absent or that can be not recorded. So that leads to missing values. So the missing value is very important to identify. Then identify that how many missing values are there. Just quantify that missing value per variable. That, let's say one feature has how many missing values. Let's say age is a column or age is a feature. In that age column, that how many values are missing. If it is more, then what kind of pre-processing step you need to identify, you need to do, that also need to be identified. Or if it is less, then what kind of pre-processing step you will do. So before pre-processing, you have to identify these things and investigate patterns of missingness, whether the missingness is random or there is a systematic way of missing, or there is any structural pattern. You can identify that. Based on that, you will have a better decision power for doing pre-processing. Third goal is detect outliers and anomalies. Outliers, that sometimes some data will deviate from the expected patterns. For example, age. So age is a column, and you find a data which is recording as 375 is the age. So 375 cannot be an age of a person. That means there is some mistake during entering or during capturing the data. So that is an outlier. So you have to identify the outlier and what type of outlier it is. Depending on that, whether the outlier is important for decision making, or it is not important, or it is by mistakenly somebody has written that data during the data collection, that you need to identify. Once you got that, then only you will have a better understanding about the outliers, and you can apply different types of outlier removal techniques in the pre-processing. Fourth one is find patterns and relationships. This is another goal. Pattern means just analyze the data to discover trends, relationship between variables. Because you see, sometimes you got a data set with 100 features, but all features are not important to find out the output, or they will not important to give you the output. I'm giving one example. Let's say that roll number. So roll number, if you want to the problem is to find out the student will get A grade, B grade or C grade. You want to predict the grade of a student, and the roll number is one column is there. We know that roll number do not have any effect on the outcome of the result, because roll number do not have any effect, that we know. So that kind of relationship you have to find out, whether there is a relationship between input variable and the target, or if there is no relationship. If there is no relationship, then you just remove that. Then you do that. Removal is a pre-processing technique. You can remove that. So you have to analyze the relationship between dependent and independent variables. Then compute summary statistics. Summary statistics means mean, median, mode, variance, quantiles. These things you can find out, and accordingly you will decide what kind of pre-processing you will apply. Next is use visualizations to better understand the data, like histograms, box plots, scatter plots. General box plots and scatter plots are used for finding out whether there is outliers or not. It is easy to identify outliers using box plots. To grasp distributions, relationship between different variables easily. If you have these plots, easily you can identify. So these are the goals of EDA. So what it helps to detect? The EDA helps to detect problems like missing values, outliers, duplicates, imbalanced classes. Also, whether the class is balanced class or imbalanced class, that also can identify relationship between variables. And if you do that, then you will have a better decision about, you can make a better decision about pre-processing. So what actually it says, EDA does not just look at data, it tells us what needs fixing. It is not just exploring. You have to identify that these are the problem areas and what will be fixed for that. That will be done in the pre-processing. And what pre-processing will do? Pre-processing is the action that fixes it. It will identify what needs to be fixed, and the actual action will be done by the pre-processing step. Now comes, once the EDA is complete, next we will do the pre-processing. So let's say what kind of pre-processing will apply on identified anomalies, missing values, outliers, or the problems what is identified by the EDA. So data pre-processing is the process of transforming raw and messy data into a clean and structured format which will be suitable for applying machine learning model. So from noisy data, from messy data, we need a clean data so that these anomalies should not be there. And if you got that, then only it will be better for the models to learn. So it addresses real world data issues like missing values, inconsistencies, errors, and incompatible formats. Okay. So let's see what are the pre-processing approaches. So first pre-processing approach is, if you find out that a missing value is there and what kind of missing value, then you have to handle it using pre-processing. So we call it as handling missing value. So there are certain techniques that will be, in gist I will discuss what are the techniques. Second is handling outliers. If there is outlier you have detected it during EDA, then how to handle that outlier. Data transformation and scaling. Do we need any data transformation and scaling of the values of a particular feature? That also a part of the pre-processing. Then you encoding categorical data. And fifth one is, if you have duplicates and any other inconsistencies, how to deal with that. So let's see one by one. First one is pre-processing. So you see, I have mentioned lots of pre-processing techniques. So let's go one by one. First pre-processing is for missing value. So in missing value, if one solution for missing value is a deletion. If a value is not there, then you delete that. So what actually it does, it removes any row with a missing value. That means you have identified that this is the row which contains some feature values are missing, then whether I need to delete the total row or I have to do something else. When you will delete it, it will be best when missingness is less than 5% and random. That means randomly, let's say in one row, less than 5% data is missing. So you can delete that. Okay. Example, in 1000 rows, 20 missing. Means 20 rows has missing. So you can delete those 20 rows. That may not affect. This is one decision you can make. And how to identify whether 20 rows are missing? So during EDA, you have identified that yes, these are the 20 rows which has missing values, and total data size is 1000. And safely you can remove. That will not impact the model. Another one is that you can impute, means apply imputation. Imputation means replace these missing values by using mean and median. So when you will do that, now when the number of data is small and small percentage of missing value is there, and the data is in a normal distribution set. So that means what we'll do, Now, instead of deleting these rows which got missing values, you can replace them with some central tendency values like mean and median. For example, let's say there is a age column. In age column, 2 or 3 values are missing. So what you can do? One solution is that you can delete them. These rows which contain missing value, you can delete them. Another solution is that I will not delete it because it is maybe very useful for my task. So let's do one thing: find out the mean of that age column, and whatever mean is coming, I will put in the area in the field which do not have age. So if you got NaN or not a number means, you already have discussed in the last class that NaN means the value is missing. So you calculate the mean of that column of that feature and replace the NaN with the mean. Let's say it is 35. So you can replace with 35. This is one option. Third one is mode imputation. So if it is a numerical value, you can take mean or median. But if it is a categorical value and you want that we will not delete this row, rather we will replace. So what we will do? We will take mode. Mode means most frequent data in that column. So if it is a categorical value and you want to replace that missing value, missing place in column, so find out frequently used in that data set and replace that. Let's say city is a column and you find out of 1000 rows, let's say 50% or more than 50% data is using a newer. So you can replace, means whatever mode is coming. So that mode you can replace, let's say newer, most common. Another method is forward or backward fill. So instead of taking mean or replacing mean, one very basic thing that if it is a time series data, if it is a very simple numeric data, it's okay. But the time series data means during time passes, the data will vary. Let's say stock market price at a particular time, yesterday price and today's price, there is a dependency. And if somebody is collecting the price of a market and of a particular stock, and he got a missing value in a particular day, his previous value is there and next value is there, then what you can do? You can use forward fill or backward fill. Forward fill means that use next rows data or use previous rows data is backward fill. So whatever is there, you just replace it. For example, here it says stock price missing, use yesterday's price, that is called backward fill, or use tomorrow's price, that will be forward fill. So that also can be done. Another way of pre-processing the missing value problem is to interpolation. Do the interpolation. Interpolation means if it is a continuous time series data. Continuous time series means you are collecting, there is a sensor in a particular room and you are collecting temperature of that room to create a data set. So temperature at each hour. So if let's say at 2 p.m. the data is not being collected, but you have collected the data in 1 p.m. and 3 p.m. So what you can do? You can take 1 p.m. data and 3 p.m. data and average that and interpolate it and put it in the second 2 p.m. As the missing value. Okay, this is called interpolation. Or you can use KNN imputation. KNN, there is a KNN model available, K nearest neighbor. So you can apply KNN on the total column of the data, find out K most similar rows for a particular row, and whatever value is there for these K most similar rows, you can replace that also. Or there is another technique called regression imputation. Regression imputation means predict, let's say one value is missing. What you can do? You can use some regression technique to predict that missing value. You can use that also. So most common technique is deletion, then mean, median and mode imputation. And if it is a time series data, then you can use forward and backward fill. And if it is a continuous time series, like I'm telling this 2 p.m. 1 p.m., then you can use imputation. Or for general missing value also, you can use KNN imputation or regression imputation. Imputation means replace. These are the different techniques used for missing values. Next is handling outliers. So how you will handle outliers if the outliers are there? Outliers means those which are not expected values. So one common approach is trimming or removal. If you got a outlier, it's very clear, means it looks that it is error. For example, age is 200. So it is a clear error. We know that from our knowledge, the age cannot be 200. So it's an error. So you can delete that. Okay. So one technique is removing or trimming. That delete rows with outliers. If a row contains outlier, you can delete that. And when it will be used, now when you are very sure that the outliers are errors, clear errors. Okay. For example, in a salary column, if the salary contains $12 million, so generally $12 million is not a salary for anyone. So if you know that this cannot be a salary, so you can remove that because it's a clear error. Another technique, capping. Capping when the outliers are genuine, means yes, the data is correct, it is not error, genuine, but it is outlier, it is extreme. So in that case, what you'll do, you can cap it, means replace extreme values with some kind of threshold. Okay, for example, set values than 99 percentile to 99 percentile. That means you pick a threshold. If any value reaches that threshold, it will be replaced by the threshold value. Okay, this is one called capping technique. Another one is the transformation. Transformation, when transformation will be used, now if your outlier is very skewed, means the data distribution is very skewed towards one direction, it is very skewed. So what you will do, you can do a log transformation. So if you do a log transformation instead of removing or deleting, that will make the skewness less affecting the data. So you apply functions reduce outlier impact. That is when it is best used when there is a skewed distribution. Okay. And like salary, if means most of the people's salary is between 10,000 to 50,000, and you got 2 or 3% salary which is 10 lakh. So in that case, what you can do, because they are clear outliers and they are correct values, not errors, so you can do the log transformation so that they will come to a particular range. Okay. Another one technique is called flooring or ceiling. Flooring or ceiling means you just cap it. Like for example, set a minimum and maximum value. For example, age. If there is a age 200, so you give a cap. It cannot be more than 120. So it will be, it's similar to capping. So it will come to 120. Okay. Another method is binning. So in binning, what happens? It convert continuous to categorical values. So if you have continuous values, what you can do, and that continuous value contains outliers, so you can bin them. Bin them means create one category, like 0 to 18 one category, 19 to 35 another category, 36 to 60 one category, and any value present fall in that, it will be that category. So these are different techniques that can be applied to handle outlier depending on these situations. Okay, and these situation outlier are detected during EDA. Third processing step is transformation and scaling. Sometimes transformation is required or scaling is required. That means in some machine learning algorithm which uses distance as metric. Okay, so like SBM or like KNN, where distance is being used, or any linear models, the distance is used in their algorithm. So in that case, the data must be scaled to a particular format. Otherwise, if the variation of the data between different columns is more, then you may not get good result. That's why scaling or transformation of current data to another format is required. So what type of scaling is there? Fast scaling technique or transformation technique is there called mean max normalization. You can normalize the data. So normalized data means how it will work. All the value of all columns will come between the range 0 and 1. Okay, so I will do that. So the formula here, that x minus mean divided by max minus mean. That for every column, find out maximum, find out the minimum value of that column. Then for every data in that column, you just subtract mean from the data, divide max minus mean, the difference of max minus mean. So if you do that, what will happen? Now every data in every column will come between, or will be converted into between a value 0 and 1. So it will be bounded when the data is bounded, or it can also be used in the neural network, also in ML model also we are using. Another kind of transformation or scaling is standardization. We call it a Z-score transformation. So what we'll do, now for every column, we'll convert the distribution to a normal distribution. Normal distribution means the data has center means mean will be 0 and standard deviation will be 1. How to do that? The formula is that you calculate the mean of the column and you calculate the standard deviation of the column. Then for every data point, you subtract mean from the data point and divide the standard deviation. So if you do that, so it all the value will be converted to a normal distribution, because normal distribution is a very good distribution to apply any ML algorithms or any DL algorithms also. So they are normally distributed data when will be used, or in any linear model and PCA also we are using this. Another one is robust scaling. Robust scaling means what you do, instead of using standard deviation here, you are using standard deviation in Z score or standardization, you use IQR, interquartile range. So if you do that, this is called another kind of scaling. So x minus median, instead of mean you use median divided by interquartile range. So if the outlier is present, then you can apply this scaling also. If you do not apply outlier removal techniques, you can also apply this one, transformation, so that the outlier will not have much impact on the output of the model. Another one technique is called log transformation. So if the data is skewed, so the skewed means you do the log transformation, like already you have seen in the outlier case. Here also you can do that. So either use log of that value, or you can use log of 1 plus that value. Okay. So these are the different scaling and transformation techniques available under pre-processing. Next step is encoding, and this is very important. Encoding the categorical data. Because one thing you remember, whether you are applying any machine learning technique or any deep learning technique on any data set, all the data must be converted to numeric form. Because these algorithms can only handle numeric data. So if a data set contains non-numeric data like categorical data, pass, fail, male, female, etc., then they need to be converted into numeric form. Okay, and also when we'll discuss the NLP part, in NLP everything is a text. So the text cannot be solved, cannot be used by the any ML algorithm or any DL algorithm. So we have to convert them into numeric form. We call them as embedding. That we'll discuss how to do that, and this is very important part. Similarly, here also, if you got a data set and some columns contain categorical data, then you need to encode them into numeric form. What are the different encoding techniques available? First encoding technique is called label encoding. It is very simple. Label encoding means now when your data is ordinal category data. Categorical data are of two types generally: ordinal data and nominal data. Ordinal data means the category is, let's say, small, medium, and large. So it is ordinal. That is order. Clear. Small is small, then medium is a little bit bigger, then large is biggest. So if this kind of output is there, of data is there, you can use label encoding. Label encoding means you can apply convert small to 0, medium to 1, large to 2. This is very simple. It's called label encoding. Another encoding technique is called one hot encoding. This is very important. One hot encoding, what it does, in one hot encoding, it will be used when you have nominal categories. Nominal categories means there is no order in the categorical value. Let's say red, blue, male, female. These are nominal categorical value. So, and it will be used when the number of nominal categorical value is less than 10. Okay, and what it will do, it will create a binary column for each category. Okay, so how it is doing, let's see. So for example, what it will do, let's say I have a column, let's say column X, which contains values red in one row and blue in another row. There is a data set and some data is like this. And red is a categorical data, blue is a categorical, they are not numbers. So you cannot apply label encoding, because label encoding can only be applied if there is a inherent ordering between these, because in red and blue there is no inherent ordering. So we cannot directly write red as 0 and blue is 1, you cannot write. So what you can do, you can apply one hot encoding. What one hot encoding is doing, now for each category, there are two categories, red and blue. For each category, it will create two extra features or columns in the data set. Let's call it as X red is one column, another column will be X blue. So if first row contains red, so what it will do? It will convert this into binary. Red means X red will be 1, and blue means in blue column it will become 0. That means this red is converted into two values, 1 and 0. Similarly, blue will be converted because it is not red, so blue column will be 0, and here blue column will be 1. Means this X, there was one column. Now after applying one hot encoding, it becomes two columns, and for each column is representing one category, and they will be converted to binary. If it exists, that column will be 1, and if it does not exist, it will be 0. So this is called binary or one hot encoding. This is very important. This is one way to convert nominal categorical data. Another one is dummy encoding. Dummy encoding is similar to one hot encoding, but it will avoid to use two columns. In this, you are using two columns, but here it will create one column, but it will have same effect. What it will do? Instead of creating two columns, it will create one column. Let's say it will say that X is red. So is red means if it is converted to X is red. Is red, so it will become one column. Now X is red, yes, first row is red, so it will become 1. Second row it is blue, and X is red is false, that means false, it will become 0. So in this way it will be creating. Okay, this is called dummy encoding, and it will be used for linear models. Then comes frequency encoding. Frequency encoding means replace category with its count. That means for every category, you just count how many times they are, and red contains 5 times. You replace red as 5. Wherever you find red, you just put 5. And let's say blue is there in that column 10 times. Wherever you find blue, you put 10. So this is one way you can do encoding. Is it okay? So these are the different encoding of the categorical data. Next pre-processing technique is duplicates and inconsistencies. If duplicates are there, then what you will do? If duplicate data are there, what you will do? So one approach that very simple, if it is nearly same, means almost same, so or exact duplicate, just remove them. By mistake, same data is inserted in the data set more than once. So identify them in EDA. During EDA process, you identify and you just remove all of them, and just one will exist, all other will be removed. That is simple. Another one is partial duplicate deletion. Means they are not exactly identical, but they are near duplicate. Near duplicate means sometimes you will have same name, address, everything is same, but the timestamp is different. So if the timestamp is not important for that task, so why should you keep two? You just remove one. So that is called partial duplicate deletion. Third one is standardization. Standardization means if in one column, so the Newark is written as NY or N.Y or Newark. So you convert everything into one format. So we call it as New York. So it is one kind of duplicate, but they will be treated as different if you are using using any ML model. So if you apply one hot encoding or anything, so they will be converted to different, but they are actually same. So you standardize them into one format. Or case normalization. Basically, this case normalization is being used in our NLP. Case means sometimes you will see some text is in capital, some text in small letters. So you convert them into everything into smaller, everything into capital. Generally, it is small letter. So here, let's say you have New York in small camel case, and this is New York in capital. So all can be converted into one lowercase. So these are called case folding or case normalization. So these are the approaches that can be applied for pre-processing for duplicate and inconsistency removal. Okay. So these are the different steps for pre-processing. Once you do the EDA, you identify wherever the inconsistencies and what kind of inconsistencies, then you apply appropriate pre-processing technique to remove them. So that after applying them, you will get a clear data. Once you have clear data, third step in the pipeline is feature engineering. Feature engineering is what? Now you have already features in the tabular format. Sometimes you after analyzing the data, you got to know that I can create new features out of the existing feature, which will may be important to decide the output. So that is called feature engineering. So what is feature engineering? It is the process of creating new, more informative variables or features from raw data to improve the performance of the machine learning. So you can create new. So what are the different techniques available? First one is polynomial features. Polynomial features means if you, let's say, age column is there, and there is a known its relationship is non-linear. What you can do? You can create a polynomial feature, means age square, age q, or if there are two other features are there, you can multiply them, create one feature. We call them as polynomial feature engineering. Okay. Another one is interaction. Interaction means, let's say, income is one column, education per year is another column. So by analyzing, you, if I multiply these two, whatever new feature is coming, that will be more good feature or is the best feature to predict my output. So you can do that. So multiply the different features. Another one is binning or discretization. Binning means if you have continuous values, you can convert them into categorical values like this. Binning. Another kind of feature engineering is time decomposition. Sometimes in one column, the date is there. But for your analysis or for your task, if you decompose the date into, let's say, three different columns, one will be year, another one will be day, another one will be month. So that also you are creating from one feature, you are creating multiple features. So that is one kind of feature engineering technique. Another one is you can create a ratio or a difference kind of feature. Let's say there are two columns present. One says weight in kg, another says height. For, let's say, to predict disease or not disease. Okay. So sometimes weight and height alone may not be good feature. If you convert them in BMI, we know BMI, you can create another column which will be just using the weight column and height column. Using this formula, you can create one new column called BMI. So BMI can be more a good feature than existing weight and height. So you can do that. So these are called feature engineering. So these are or some other techniques are also there, but these are the basic feature engineering techniques. So once you do the feature engineering, you have cleaned the data and you got features which is required. And another feature engineering here I have not mentioned is that you can remove some of the features. We call them as dimensionality reduction. Sometimes you got many features, but they all are not important. So you can remove them. Okay, there are many feature selection techniques available which will be used to select it, or there are some dimensional reduction technique available like PCA, LDA, LLE, different types of dimensional reduction techniques are available which can be used to reduce the dimension. Okay, so these are the three parts of the pipeline for doing ML. First is acquire the data. Second is do the EDA for pre-processing. Once you identify wherever is the inconsistencies, what type of inconsistencies, then apply appropriate pre-processing technique to clean it. Then once you have cleaned the data, then you can do add some new features using feature engineering techniques. Once you have a very good cleaned formatted structured data set, then that can be given to the next step, that is modeling. Okay, is there any doubt? So from for today we'll stop here and we'll go for the practical part where we will see some of these techniques. Is there any question?
Okay, let me unmute then. Yes, you can unmute yourself. If any question, you can ask. Yes. If any questions, you can unmute yourself and ask. Okay, I don't think so for the hands up.
Okay, so let's go for the hands up. Okay, is it visible?
Yes, Biju.
So what we'll do, we'll try to cover some of the important pre-processing ED and pre-processing techniques here, which I will also share this with you so that you can work on that. So for doing EDA or pre-processing, first step is load the data. So for loading, we have to import some of these libraries. Like here, pandas is required because we have to load the data on the pandas data frame. NumPy is required, and to plot or visualization, we need matplotlib or c1. These are the plotting libraries available under Python. Okay, so first, what you do, you execute them. Next step is load the data. So here, what I have done, I have loaded a Titanic data set. So the dataset is already there in the C1 library. So I have used C1's sns.load dataset Titanic. What it will do, it will load the dataset in the data frame. And once it is loaded, I have displayed the dataset here. You see, so this is the first 5 rows of the data set. Survived, P class, sex, age, is SIBSP, park, fair. These are the features, and whether alive or not alive, that we want to predict. So that will be our output. So this is no, yes, it's given. So you see, some of the data are numeric, some of the data are not numeric, some are categorical. So we'll do the pre-processing step for accordingly. The data is there. Next, first EDA is inspect and understand the data set, means find out basic information, because until and unless you are not aware what are the data available, then you cannot apply any kind of pre-processing step. So the first step is this, to find what are the column names available. So for getting the column names, already we have discussed for a data frame df.columns. So you just use df.columns, and I am putting them in columns variable. I just taking a for loop to print all the columns one by one. So it is printing all these columns: survived, PC class, sex, etc. These are the columns. Now, once you got to know about the columns, then finding the basic information about the column. This is very important. Let all information in one place you can get using the function called info. So you just use df.info. If you see, df.info will give you a description, basic information about the data set present here. So here you see survived. So how many non-null values? 891 non-null values are there. And what are its data type? It is integer. So like this, that means there are 891 and some are 714. Here one is 203. That means only these many values are there, rest are missing. These many values are there, rest are missing, because total number of row is 891. Okay, and some of the data types are integer, some are object, some are float, and some are category. So object data type means integer already you know, float you know. Object means it's a mix of string or text kind of data. They are called object. Categorical data is a special type of data in this data frame, which is representing a category. Okay. So from this you got to know that how many number of rows are there and how many non-null values are there, how many null values are there. Exactly how many null values are there, you can directly subtract it. Otherwise, there is another function available which will find out the null values. So to get the number of rows and number of columns, just use the df.set. So there are 891 rows and 15 columns. Okay, means 15 columns means out of 15 columns, 14 are feature, one is your target, and number of sample is 891. So data type already we have seen from the info. Also you can get the data type, or you can directly use df.d types to get the data types. Next is to find number of unique values present in each column. This is important. How many unique values are there for every column? So there is a function called df.unique. If you use df.unique, what it will do? It will find out unique value in every column. So in survived column, there are 2 types of values. In PC class column, there are 3 types of values. In sex column, there are 2 types of values, male or female, like this. In age, 88 types of values. So actually, this one is important for categorical values. Numerical value also it is that much not important, but for identifying how many types of unique values present in each category column, so that will be useful for identifying. Once you get to know that, then find out the count. So this count also already you got from the info, it's not required. Otherwise, there is a function available called df.count, which will give you that for every column or for every feature, how many rows are there. So for survived, there are 891 rows which are values. And there is a age which has 714 rows which has values, rest are missing. Okay. So now comes important part. How to get the missing values? How many values are missing? So to get the missing value, what you do, you just use the function df dot is null dot sum. Is null will give you that whether a particular column for each row, a particular columns, each row is containing null or not null. Either it will give you true or false. When you apply sum over that, it will sum all these null values. So it will give you the null values count. That here in survived column there is no null value, but here in age column there is 177 null values are there. Means so null value means missing values are there. And in date column there are 688 missing values there. In embarked column there are 2 missing values are there. So you can identify these missing value using this. Next, what you will do that if you do not want to display the zero value, just you pass missing greater than 0, it will only show those features or columns which has missing value greater than 0. The 0 will be not going to show you. Okay, percentage is not required. You can also calculate the percentage. Once you know the number of missing values, you can calculate the percentage. Next comes, once you got to know how many missing values are there, what are the different types of data available, total number of rows and columns, you have a better idea about the data set. Now, to get more insight on the data part, you can create a descriptive statistics. So, for creating a descriptive statistics, means statistical information if you want to find, so the function is df.describe. So here, if you only apply df.describe without passing any argument, here I have passed this list, I have passed, if you do not pass any argument, it will automatically identify which features or which columns are numeric. For those numeric column, it will provide you the statistics, numerical statistics. But if you want to add object category or the data type which has object, the data type which has boolean, or the data type which has category, you have to specifically mention them. That include object, category, and bool. So dot is for transpose. So if you run this, what you will see? So this is the numeric summary. These survived PC class, age, SIBSP, park, and fair. They are the numeric columns. For their numeric columns, how many counts are there? Means how many values present in these numeric columns? What is their mean value? What is the standard deviation? What is the minimum value? What is the 25th percentile? What is the 50th percentile and 75th percentile? And what is the maximum value? So these information you can get if it is a numeric value. As we have already included this category and object, so there are category values are there. So categorical summary will also give you categorical and your object. So here sex is 891 count. There are 2 unique value. Top means most people are male, and frequency is 577. Means out of 891, you got 577 male, rest are female, because the number of unique value is 2. Similarly, for embarked, there are total 889 values are there, and there are 3 unique values. S, and S is maximum, that is most people are getting from are boarded the ship from S. S is some place in I don't know what place that it starts with S. 644, and like this all these values are there. So this will give you a descriptive statistics, some more insight about the data set. Once you've done that, then you go for data analysis. So here it's actually not required, that much not required, but you can do that. You can segregate which are numeric feature, which are categorical feature, and what is target. You can do that by just selecting df.select d types, include np number, columns to list. You can do that, so that the numeric column will be 1, the categorical column will be this one, means categorical features are this, numerical features are this, and this is the target. Okay. Next is doing univariate analysis. Univariate analysis means to see the distribution of every data. So here for numeric values, you can do this distribution, just do a histogram plot. So directly you can use SNS, because C1 is already imported. So SNS hist plot, what df column, KD equal to 3 means this will give you the distribution path, and bin is 30 means it will create a histogram with 30 number of bins will be used. So this is the histogram. You can get some information out of this, means these are the counts 0, 1, 2, and this is your KD plot. So from this you will see that 0 means your park 0 has more number of values, and 1, 2 are less number of values. This is the distribution. So this is another distribution for fair. So fair 500 count is 500. 500 are basically using less fare, going to give less fare, and very small amount of people who you gives more fare, means around $100 or $200. Okay. So this kind of information you can get. For categorical value also you can do the histogram. So use this count plots. So it will give you number of counts for every category. So here this one is alive. Sorry, this one first you see. Let's say how many man, woman, and child are there. So men are more than 500, women are between 200 and 300. So this information you can get. So this will give you more insight about the data. You can do that. Once you have the knowledge about the data set, next job is to, these are the things, next job is to do the bivariate analysis. Bivariate analysis means take two features and create a relationship, find out what are the relationship between them. So this is bivariate features, like what is the relationship between survived and PC class. So you see the 0 is not survived, 1 is survived. So here you see 0 means the PC class. Okay, so this survived, this 0 is means this 0 means not more people are not survived. Here less people are survived, that means. So you can do age versus survived. You can give means survived versus SIB, PSP. So you can know how survived is related to these features, whether they are actually related or not related. If they are not related, you can remove them. If it is related, you can keep them. So here most of them are related, so we will not remove anything. Okay. So these are the same thing. Will not go. Okay. Now a correlation. So for correlation plot, you use this plot called heat map. Just you call sns.heatmap, pass correlation, annotation is true, and these are the format. All the numeric feature will give you the correlation. So that correlation is PC class versus all. Similarly, age versus all. So you see these are highly correlated because PC class versus PC class obviously highly correlated, and if they are less correlated, like this one and this one, PC class versus pair, they are less correlated, and your PC class similarly are also fair is less correlated, and these two are highly correlated, means SIB, PSP versus PARC, they are highly correlated because the color is this one 41. Okay, so how the features between themselves are correlated, that can also be give you some insight. If the two features are highly correlated, then safely I can say one feature you can drop. If they are not highly correlated, you can keep them. Okay, so this information you can get from this heat map. Okay, now come to our, once you have done this, now let's see how to do the missing value pre-processing. So what we'll do for missing value? So here this is the heat map. I've just created heat map. Already we know what are the missing values. So what are the strategies for doing? Now you can drop rows with missing value, or drop row with more than 50% of column values are missing, or you can drop columns with very high missingness. So you can do that. So how will, or you can impute them with mode, median, and mode, or KNN imputer, like we have discussed. That we'll see one by one. So first, age, embarked deck, and embarked town, they have only the missing values. Okay. So what we'll do? So drop rows with the missing value. Only do this if there is only few missing values are there. Okay, so what we'll do, just you use df.drop na in place equal to true, it will drop all rows which contains missing value. Okay, if any row contains missing value, that row will be going to drop. So for dropping, use drop na function. Okay, But drop rows with more than 50%. How will do that? Now first you calculate which columns has more than 50%. You have the 50% threshold, you calculate it. Then using that threshold, you drop it using df.drop_na. So if you do that, the rows with more than 50% column is missing, then these rows will be dropped. Okay, means drop na function is going to be used. Now, if you want to calculate the percentage of missing value, already you have done it. So df dot is null mean. If you do that, then it will give you the percentage of missing values. Okay, and based on that, you can also impute them. So one imputation is using for categorical column. How will impute them? You use mode. So calculate what will do here. I am written a for loop for column in the categorical columns, means all category column already we have collected. So for all category column, it will go one by one, find out whether they have missing values. If they have missing value, you calculate the mode, df call dot mode. Once you got the mode, just fill na. Fill na means wherever there is a missing value, you just fill them with the mode which you have calculated for that column. So it will, as it is a for loop, so it will take every categorical value and calculate their mode from that column and replace wherever there is missing value in that column. It will impute the mode. Okay, so like here if you apply, so this impute embarked will be input with s, because s has more number of times present, so the mode of embark is s, so s will be replaced. For deck it is c, and for embark town it is Southampton. Okay, similarly to impute numerical columns, you can use mean or median. So here I have used median. So df call dot is null any if there is any null value present. Similarly for every column in the numeric column, you can do that. So you calculate the median for every column, then fill na will fill that column wherever there is a missing value with this mean. So with this median, you can do the if you do the mean, just you replace your mean. Okay. There is another missing imputer called KNN imputer. So the KNN imputer, this algorithm is already implemented. It is present in the sklearn library. So you have to import that. So from scikit-learn, or we call it as sklearn dot impute, in this library, from this library you input KNN imputer. So KNN imputer will automatically impute. You don't have to do anything. Just you create the imputer class, create an instance of the imputer class, call KNN imputer, pass neighbor. How many nearest neighbor you need, that is up to you. Let's say I passed 5. So if it will take 5 nearest neighbor, and used whoever has maximum value, that will be going to be used for the imputation. So what will do? Df numeric columns impute dot fit transform. So this fit transform, whatever imputer is created, that fit transform will transform them and convert every missing value, applying this KNN imputer, and replace this missing value with this KNN. Okay, you can also do group by using group wise imputation, group by sex and age, then transform using a lambda function. That also you can do. Okay, so this is called your missing value. How you will solve the missing value problem. Next is check for duplicates. So if there are duplicates, what will do? So duplicate means if it is totally duplicate, you can remove them. So first you have to identify where is the duplicate. So I will do that. Df dot duplicated, the function name is duplicated dot sum. So how many of them are duplicated? So you will see in this data set, 108 rows are duplicated. The same values are there. So if you see display them, you see these are the duplicate, means some value are duplicated, not all. So you see here male, 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 male. So these are all males. Okay, so, means some value are duplicated, some value are not duplicated. Okay, so all 108. So we cannot remove all 108, which are exactly missing value, which are exactly same. These can be removed. Okay. Next comes outlier detection. So here outlier means first you do the box plot. So from the box plot, for every column, you will get which values are outlier. So for this PC class, so it do not have any outlier. Now you see for this one, these are the outlier class values. Okay, which one is? It is age. In age, they are the outliers. Okay, because most of the people are between 0 to 60. Between 20 and 40, and these people are outliers, extreme high. Okay, And here also in SI, BSP also some outliers are there. So you can identify outlier by using the box plot. Once you identify the outlier, then there are different strategies of outlier. One is just remove the outliers directly, delete them, or you use interquartile IQR method, or you can use Z-score method, or you can do the capping or transferring, what we have discussed. So these things can be done. So here, to remove outlier, I am using interquartile range. So here DF numeric columns means I am using the numeric columns, and for that I will use 25th interquartile range is 25th. What it will do? It will calculate the 25th percentile for value and return in Q1, and it will calculate 75th percentile and return it 1. Then I will calculate the interquartile range. How will calculate? Now Q3 minus Q1. This is the range. Now the lower bound will be what? Now you can use Q1 minus 1.5 of IQR, and the upper bound will be Q3 plus 1.5 of the IQR. So I'll set what will be the lower bound, what will be the upper bound. This is up to you, whether you take 1.5 or something else. That is up to you. Once you set that, then any value beyond this range will be removed. So how will do that? And DF not DF numeric column less than lower bound, or DF numeric column greater than upper bound. That is any means any value. Here axis is 1. Axis 1 means it will take the column. Okay, and in columns it will be applied. It will find out the outliers, number of outliers. So these are the number of outliers. So say before removing, so you will remove them. So before removing there are 891. Now after removing you will get 598. So all outlier which is beyond this range will be removed. Okay, in this way you can remove them. Okay, and there are other techniques I have not mentioned. You can do that. Next is feature encoding and scaling. So I have already told you that in ML everything should be come into a standard format. If some value is range is high and some values range is less, then your machine learning algorithm is not doing well. So we need to standardize them or normalize them. So there are different techniques available. So first, before scaling, let's discuss the encoding. So encoding means categorical value. You can encode them. If it is a nominal, you can use one-hot encoding. Or if it is a ordinal, you can use label encoding. So let's see. So these are the categorical columns: sex, embarked, class, who, adult, male, deck, embarked town, alive, alien. These are the categorical columns. Now let's say you want to use one-hot encoder. So one-hot encoder, if you use the already one-hot encoder method is there, you just import them from sklearn.preprocessing. So from sklearn.preprocessing, import one-hot encoder. So NumPy you just import. Now we'll do the encoding. How will do that? Now first you select the categorical columns. So categorical columns you select df.select d type. This object include object category boolean column to list. So it will convert them into a list. So we'll get the categorical column list. That means this list will created here. Once it is done, then you apply one-hot encoder. So call the one-hot encoder. Pass handle unknown is ignore. If there is any unknown value present, you ignore that, so that you pass. Otherwise it will give you error if there is any unknown value present. Then sparse output false, so it will give you dense output. So now you got the encoder. Once you create the encoder object, now you apply fit transform. So like in KNN imputer also we have done the same thing. First you create the object, then apply the fit transform. So fit transform will actually applied, this encoder will applied on the categorical columns. So just encoder.fit transform, you pass all the categorical column, so all will be transformed to one-hot encoding, and it will become the encoded data. Okay, now you add them in the data frame. So pt.data frame, you just add encoded data and these columns which you got for the categorical. So once you got, now the new data set what will be created is this. So previously for every let's see here, there was only sex, one column sex was there. Now we remove this sex and replace with this one-hot encoder, sex female, sex male. So first one is actually male. First this row contains male, so male becomes 1, female becomes 0. This row contains female, so here female becomes 1, male becomes 0. Similarly, embarked. There are 3 embarked towns. So embark is C, embark Q, and embark S is there. It's not showing because it's lengthy. That's why it's not showing. So first row is embark S, so both are 0. Embark S is 1. Now second row is embark C, so C is 1. Rest 2 are 0. Like this, all other encoding has been done. Okay. So this is called one-hot encoding. And if you want to use label encoder, what we'll do? Now you can similarly call label encoder, just import the label encoder from sklearn pre-processing, like you have means imported the one-hot encoder. You initialize a instance of that label encoder. So label encoder object is created. Now let's say I want to encode the column sex. Let's say, because sex is not a nominal feature. Let's say I want to encode that. So what we'll do? Now you just call the label encoder and feed transform, pass that column. Df column to encode is the sex. So df sex. So it will create a new column and I'll put it in df target. Okay. Now if you see, you will get this as the output. Df target is this is the output. That means the value present in the sex column, wherever there is a male, it will be 0. There is female, it will be 1. Okay. Now there is another one-hot encoder I have applied. So same thing, will not discuss. Next comes scaling. So scaling is a transformation. Once encoding is done, you can do the scaling for the numerical part, numerical values. So for numerical values, if you want to apply scaling, there are two scaling methods are there. One is min-max scalar, another is standard scalar. Standard scalar is your z-score. Min-max is the first one which we have discussed. So if I apply standard scalar, you just, if you apply anyone, what you do? First you create the object. Just call the function. The object is created. Then just call the fit transform. Remember, fit transform is very important to actually apply. So here scalar.fit transform, you pass df encoded, then pass the numeric columns. So all numeric column will be transformed using the standard scalar. So you see all values has been changed according to z-score formula. That is, it will be in a numerical, sorry, it will be in a normal distribution. That is the formula is that x minus mean divided by standard deviation. So this formula is applied. Okay. So you can also apply instead of standard scalar, you can also apply min max scalar. So for that, you just instead of standard scalar, you apply here. You just write min max scalar. Again, same fit transform. So what it will do? Every value will be converted between 0 and 1. So that can also be done. Okay. So this is called the transformation. Now once you have processed the data, now your data is clean, processed, you have removed outlier, you have removed missing values, means deal with that, and all pre-processing has been done. Next you do the feature engineering. So feature engineering, if you need to create some new features, you can do that, or you can, if you want to drop something, you can also drop that. So here what I've done, I have dropped survived column. Why? Because once the feature engineering is done, next step is you just create a put in a format so that the ML can be use it. So for that, what I need, all feature will be one value, the target will be another. So for this, what I have done, I just drop the survived, because survived is my target. So I got all the features in X and use the survived so that I got only the target. So in Y, I have the target values. In X, I have the all features. So if you see the set, it is 891.32, and for test it will be only one. Okay, 712 and 1. So you do that, and once this is done, now you got everything. Next step is that you split them. So that we will discuss in the next class. Is there any question? Yes.
Yes, let me unmute them and you can ask the questions. Yes, now you can unmute and you can ask the questions. And all of you just practice, okay? What are the things sir told? You just practice this
Sir,
thing.
I had a question regarding the
Yes,
workshop.
Yes, Arunday.
Yeah, so sir, all the NLP students, will they have to pay to attend those classes?
No, which one? Machine learning
Sir,
speech processing?
yeah.
No. Not you got to pay. Directly you have to
So
join.
sir, like we will get the link in the WhatsApp group only.
Yes, I will give the link in WhatsApp. But you have to
Okay,
attend
sir.
the inauguration ceremony. That is compulsory. Others you are attending on going to attend or not, that depends upon your interest. Okay, as you have already seen, so many resource persons are there. I have also requested to Nayan sir also to attend that one.
Yes, sir.
So definitely we'll get something from that. and you are on free entry. No registration fees. Okay, I will share the link only.
Sir,
You
can you please repeat what do we have to attend? Like I didn't get that part.
inauguration session, that 9:21 inauguration session will be there. That you have to attend because the register will be there, all those things. So we need crowd. Okay, at that time. After that, depending upon your interest, whether you want to learn, then attend. That will be 3 sessions will be there daily. Okay, 10 to 12:30, 11:30, then 12 to 1:30, another 3 to 4:30. Let me share the whole schedule also with you today in group so that everybody can know. Fine. And any other question related to today's class, you can ask, otherwise you will stop. And recordings will be uploaded today only.
Good evening, sir.
Yes.
No, sir, actually, I want to ask that whatever the sir is teaching us, where can we practice that and how can we learn in that?
Yes.
I repeat the question.
So, whatever the sir is teaching us, like where can we practice and enhance ourselves?
How will practice it?
So, practice and extra if we want to explore in something like that.
Oh, no, once I complete tomorrow, I will complete the whole process. Then I will give you some data set. Okay, and you apply the same step to create a model. Okay, and test whether your model is performing well or not.
What is
So
important? Sir, what sir told? You will give one data set, you have to test the same thing in the new data
means
set.
the process I have mentioned today. I have mentioned the 3 processes. So next tomorrow I will discuss last 3 processes so that a model will be ready. Okay, and then we'll create one simple, take a simple the same Titanic problem and apply the machine learning techniques to create a model and test whether my model is good or bad. And once we complete this process, then I will give you some data set so that you can try on that. You can create a model using the same steps and see how your model is performing. Is it okay?
Yes, sir.
Okay. Tomorrow,
Hello, sir. Can you hear me?
once I complete, then I will give you some data set, some problems, so that you can practice on that.
Okay, then I think we should stop here. Okay, recording
sir.
will be uploaded.
Thank you.
I have already shared this brochure and this tentative schedule.
So tomorrow we'll complete this ML part. Then from the next class, means next to next class, we'll start the NLP.
Next week means after 13 only, from 9 to 10.
Only, yes.
No classes.
On 14 or 15, whatever is there, the day,
Yes.
we'll
At
start NLP.
Okay, thank you very much.